Oh, we're live. How's it going?
Good.
Not too
Thanks for
bad. What a
joining.
surprise,
Yeah,
wasn't it?
I know. It's another month, another Azure Container Apps community live stream. I'm joined today by Nick and Simon. Y'all want to say hi?
Hey, guys.
Hey.
So Nick works on Dapr and other things on container apps, and Simon works on, I don't know what you work on. You work on a lot of stuff.
Yeah, I'm the intermediary for all kinds of things. Mostly officially, I'm supposed to be working on add-ons as well as code to cloud. And those are the things that I'm also trying to hopefully showing off today.
Yeah, those are the big announcements this Ignite. Simon, you were at Ignite. Nick, didn't see you there. I don't think you were able to get in, but I saw you joining remotely on one of the sessions.
Yeah, I was there in spirit.
Simon, do you have
Yeah,
anything?
I was at Ignite. This was my first Ignite. It was nice to see kind of how Microsoft, messages many of these things that we work behind the scenes. So it was fun. It was good.
Yeah, I was there as well. It was pretty fun.
Do we, at this point, also cover the things that we found interesting at Ignite, or do you want to talk about that?
Yeah,
Anthony?
like what did you like at Ignite?
So for me, because of the demo, which we will be seeing, I actually tried to kind of come up to speed on a lot of the AI stuff, right? How it's being built behind the scenes and all of that kind of stuff. And so I spent the weeks beforehand kind of upskilling essentially, right? And I always try to do so with a mix of like, what is the industry doing as well as what is Microsoft doing? And what I found, and this was, a lot, there's a very deep pool to be learning here. And what I found that struck me really significantly was on day 2, the keynote talked about a lot of things AI, surprise. But what really struck me was that how easy a lot of this stuff that I learned prior, and some of those things I did hands-on, right? By either using a Jupyter notebook or otherwise, like spinning up an app. And in the keynote, and there's a little bit of TV kitchen going on there, right? Where they're like something is happening behind the scenes or something is prepped. It's very refined, but nonetheless, a lot of the stuff that I first very tediously had to hammer into my head, and then secondly, kind of on some things went hands-on, looked extremely easy using some of the new products they're basically releasing. Like one of the things that comes to mind for me, for example, is model evaluation. Generally a pretty, like, that's not a day one thing that you're concerned with, right? Only if you're iterating and seriously using a model do you want to actually look at like, hey, how did version 1 of this model compare to version 2 of this model? And I mean, it was like click, and now you were reviewing both of these models front and back. I think there was product features that kind of allowed the LLMs to be kind of restrained, right? Very focused on a particular area only. So they don't break out. We don't have jailbreaks. Also, those seemed extremely easy to use. So it's really striking how much Microsoft is doing here in order to go and make this stuff accessible, right? So that's kind of the thing that was like an aha moment for me.
Cool. What about you, Nick? Did you catch any of Ignite?
I caught your talk.
Oh, really?
No, I'm just kidding, because it wasn't recorded.
Yeah, it wasn't recorded.
No, I saw. I was excited about Mark Rusinovich's and Brendan Burns. They announced the Radius, and that was a long time coming that I had seen in the works for quite a while, and so it's good to see it come to light and now being announced publicly. So that was probably one of my highlights.
Nice. And I think for me, it was actually Thomas in chat here. Kind of said the same thing. I was pretty excited to see .NET Aspire. I know that our teams have been working together to make sure that .NET Aspire deployed properly to Azure Container Apps. So it was actually really cool to see that getting some love, and hopefully everyone's trying it. Cool. I don't know, what should we do? Let's talk about the newsletter, I guess. I like, Simon, how you asked earlier about this is the part where we talk about Ignite. It's as if we have a plan. But yeah, let's talk about the newsletter. So yeah, every month we put together this amazing newsletter where we aggregate a bunch of content that you all have been putting together, as well as some product news. So I put up on the screen there the link that you can go to check out this newsletter. And yeah, so here's a bunch of links, and I've already got them open. So I'm just going to go ahead and kind of go through some of the community links that we came across in the last month or two. We actually missed the November stream because we're busy prepping for Ignite, and we're like, what can we talk about? We're like, we can't talk about anything because like we're going to wait for Ignite. So we kind of passed on that stream, but hopefully we can make up for it this time. Simon, you're going to say something.
Me?
Yeah, you kind of pointed at something on the screen. I wasn't sure where you.
I pointed at my own stuff. I'm now finally ready to do
You're not even watching what's going on here. All right.
I apologize. Now I'm full. Your attention. My attention is fully yours now.
No, it's okay. I see I'm not your priority. That's fine. I'll keep carrying on. So yeah, so this first link that we have here is a workshop that I think we shared here before. It's done by a bunch of friends within Microsoft. I think many of them are cloud solution architects, and they kind of put together a really in-depth workshop on using container apps. And we saw that they recently updated it for things like workload profiles, and I forgot what else. So they're always keeping it up to date. So if you want to learn more about how to deploy, an app or a bunch of apps to container apps, check this out.
This looks nice.
Yeah, it is very nice. Yeah, check it out.
Like the workshop. Okay. Yeah, with modules and everything.
Yeah.
Very useful. Okay.
Yeah, we should check that out. Yeah, another thing that we did in, I think, September, October, something like that. We had like 30 days of not AI, but IA, intelligent apps. And and there were a couple of articles here on how to deploy intelligent apps to Azure Container Apps. So check that out as well. And then about a month ago, oh, that's a nice screenshot of myself there. We had an Ask the Experts session. It's actually called Ask the Expert. So you have to guess which one of these 5 people is the actual expert. But yeah, so we had a session. Actually, we had 2 where we kind of presented a bit on container apps, and we tried to take some audience questions. So check out the recording if you are interested. And then on to some community blog posts. So Jonathan from Elastic deployed or sort of kind of wrote an article on how to deploy a web app, a Hello World web app. But that the Hello World part isn't the important one. The interesting one is that it's that they wired it up with with telemetry settings. I think using OpenTelemetry to send I think logs and metrics and stuff to Elastic Observability. So if you happen to be using Elastic, check this out. And the next one is Kai, who I think is in the chat, who put together a really in-depth article. Actually, Kai only puts together in-depth articles on actually comparing functions, different ways of deploying function apps and Dapr apps to container apps, and kind of comparing the performance of everything. So we kind of scroll down to the bottom. Yeah, it's a really long article. Scroll. There there's actually some results that are actually pretty interesting. So can't find it anymore. But there was a graph somewhere that I thought was pretty interesting, or a little table.
Seems like an endless number of graphs.
Yeah. So yeah, it's very in
thorough.
depth. But yeah, basically comparing, a function app that's running in a container in Container Apps, an app that's using Dapr, and a third function app thing. But I think the Dapr one was performing the best, but maybe not. We can all read it after to find out. But they all kind of came in fairly close, but I think one of them did edge out the others. Cool. And Xavier wrote this article on, actually 2 articles on how to run GitHub runners, self-hosted GitHub runners in Azure Container Apps. And yeah, so in the first article, they went through, I think, kind of setting up how to run this. Maybe using a container app, and then the second one, I think he might be using a job. But anyway, it's a nice 2-part article here on how to run a self-hosted runner, and we're seeing a lot of customers do this. So it's really great that that Xavier has actually put together this pretty in-depth article, because I think our documentation goes over how to do this with your own GitHub account, but here I think he's going through how to do this with an organization account and some of the differences there.
One might say that if someone was going to pay attention that would be responsible for some of this, they would productize this more thoroughly, right?
Yeah. Are you talking to me?
Well, really, I'm talking to you and then making a note for myself.
Okay. Nice. All right. This is an article by Giselle. We can all, I believe this is written in Spanish. On comparing container apps to some of the other things that you might be using. So a pretty in-depth article on how to deploy to container apps. And then here's one here by Massimo about resiliency policies, which Nick is going to talk about in a little bit. And yeah, so if you want to check this out, you can actually see how he's comparing, or kind of walking through how you can actually observe what's happening with the resiliency policies. So that's really cool. And last but not least, we have .NET Aspire, the announcement article for it that Glenn wrote. So if you all haven't, if you're a .NET developer and you haven't seen this yet, check this out. It's a really nice way of actually building cloud-native microservice-y kind of apps within .NET using a new stack called Aspire. Actually, Simon, you were kind of somewhat involved in this. Do you have anything to add? Anything you liked about Aspire? Anything that I missed there?
I'm not a .NET developer per se. I think they're making some smart choices on local to remote. I think that's refreshing to see. There's some good pieces around, not just leaving it onto you to package your app thereafter for cloud ready, but instead actually package, give assistance there and incorporate that into. I think a lot of frameworks still are kind of like, well, we take charge of the development and make that easier, but then when it comes to running it, you're on your own. I find it encouraging that the Aspire team is kind of trying to tackle some of these things as well, which oftentimes they're hard and you have to have opinions. In some cases, people are afraid to have opinions because that alienates others. But yeah, no, it's very promising, and unsurprisingly, I think we'll be hearing more of this going forward from them as well.
Yeah, it's speaking from the Container Apps team, we're working closely with the .NET team, and what we announced at Ignite and .NET Conf is really just the step 1 of Aspire, and hopefully, over the next few months, you'll see a lot more improvements on how Aspire apps are going to run on Azure and specifically on Azure Container Apps. All right, so that segues nicely to the rest of the announcements that we had at Ignite. So let's go over that now. So we talked about none of this stuff here. Actually, no, we did. We talked about resiliency already. But let's kind of go through this in order. So the first thing that we announced was, at least on the slide here, I don't know if it was actually the first thing we announced, was GPU workload profiles. So now you can run GPUs within container apps. And I'll kind of just show you quickly how that works here. So here I have a job that I think I already configured using GPUs. So you can just configure a workload profile that has GPUs in it. And now you can select it and then run your job or your app on that workload profile. And it should run on a machine that has GPUs. So if your app can take advantage of it, like this job here, if you go and see the execution history, the first two, I believe, were run without a GPU. And then the third one was run with the GPU. It was the same job. So you can see that, for this particular one where it's actually doing transcribing a video file and turning that into text using the Whisper model from OpenAI. I'm getting like a 3 times speed up. I can't do math on the fly, but it's faster just by switching over to using GPUs. So that's pretty cool. And the next one is resiliency policies. Actually, should we just go into the demos? Nick, are you ready? Do you want to just talk about resiliency policies instead of me?
I'm ready.
All right, Nick is ready. Okay, I'm going to switch over to your screen now. All right, take it away.
Cool. So yeah, thanks for having me on the stream to talk about resiliency. This was, as Anthony just alluded to, one of our announcements at Ignite. So resiliency is a public preview feature that you can find now in Azure Container Apps. Before I dive into resiliency and how it works in the demo, I'll spend time on one slide just setting up and explaining what resiliency is and why it's important. So hopefully you can see my screen. I didn't confirm that.
Yep, we can.
Cool.
And you'll see even better if I remove this banner. There we go.
Yeah, I think I've showed this exact slide in a previous community call that I did a demo, but it's a good one. So, with distributed systems, there are many services that are often intercommunicating with each other, right? So that could be from the outside internet to a container app running in an environment. That can be container apps within the same environment communicating with each other. And that can be container apps also making outbound calls to dependencies like a state store, message brokers, secret stores, services like that, right? And so the point here is that in a distributed architecture, by nature, there are many network requests going in and out from service to service. And statistically, when you have that many requests happening, the chances of a fault, whether that's transient or not, goes up, increases the likelihood. So that's why it's crucial that when you're building and architecting these types of systems, that you're doing it with some sort of fault tolerance in mind, so that if you were to encounter an issue, your application can either, one, prevent it from actually impacting your system, and if it does, it can actually mitigate it and get back to an operational state as fast as possible without breaking your whole solution down, right? And so that's exactly what Azure Container Apps announced and released a capability for, is the ability to provide resiliency policies to all of these network requests in an environment. And so resiliency policies are basically rules, definitions for certain resiliency patterns. So things like timeouts, which is allowing you to early terminate a long-running operation, retries, retrying a failed operation, circuit breakers, which allow you to kind of back off an unhealthy service for a limited amount of time, giving it a chance to recover and get back to an operational state, and then resuming traffic as you normally would. And then connection pools, which is really the concurrent connections to an upstream host. So with all these policies, you can combine, mix, and match them to make your applications really resilient in if they do encounter any issue, again, whether that's transient or not. So this is our first powered by Dapr feature. You might have, if you're familiar with this announcement, you might have seen some of the messaging saying Azure Container Apps Resiliency powered by Dapr. And what we mean by that is that we're taking some of the most sought after features in Dapr, so some of those best practices like resiliency, and bringing them into Azure Container Apps, making them fit into the ACA implementation, but not limiting it only to Dapr customers. Really providing resiliency, the benefits of resiliency to all ACA customers. So there's no special Dapr code or configuration needed. These policies are just available via the platform, and we'll take a look at that in depth in a second. So in ACA, there's two forms of resiliency. There's what we call app communication, or if you go look at the docs, it says service discovery communication. And this is any request being made to a container app. And so that can be, again, from like the outside, calling into a container app into an environment, or between container apps. So whether you're using the container app's FQDN or it's just app name, you can apply and define and apply those policies to any of those requests. So again, these policies will look familiar because they were inspired and taken from the Dapr open source resiliency capabilities and then brought into ACA and enhanced. So you'll see things like, you have retries, but in ACA, you're going to get more granular retries. You're going to get the ability to retry on specific response headers, or if only a certain status code is returned that you want to retry on. You're also going to get support for TCP protocol, and as well as I mentioned, a new resiliency pattern, connection pooling. And the other form of resiliency that you'll find in ACA, and this is primarily just for the Dapr customers who are making requests to their dependencies via Dapr components. So this is pretty much a one-to-one to what you'll see in the open source Dapr project, where you'll have the support for timeouts, retries, and in the very near future, circuit breakers. And so this is an example here on the screen that I'm showing where I have two container apps. It's the pub sub scenario where my container app A is publishing a message to a service bus instance. I happen to define and apply a set of resiliency policies on that outbound operation. So anytime a Dapr sidecar is making a request to a component outbound, you can define and apply a set of policies there. And then as well on the inbound operation, so PubSub's this is why I use this example, but PubSub's a kind of a unique case where you have an outbound and an inbound. They can be within the same scenario. And an inbound is anytime Dapr is delivering an event or a message to your application, and you can define a different set of resiliency policies there if you'd like. So this is fully supported in ACA today. And so as part of this public preview, we've released 3 entry points for creating and managing your resiliency policy. So depending on what's most suitable for you and your team, there's the infrastructure as code, bicep, ARM. This is just an example of the full entire schema of a resiliency policy. I probably should have noted that resiliency policies are applied to and associated to an app that is being called. So if I have container app A, invoking or making a request to container app B, you would set those policies on container app B. That's the parent, because we believe that container app B knows best on how it should be, the resiliency behavior that it should enforce on its callers. And so here in the bicep, you see I have the app name, that would be container app B, and then I have my entire schema of what that would look like for me to define my grouping of policies. Additionally, we have the CLI. So the CLI has one nice feature added into it. We'll see is this -- recommended flag that we've added. And so this feature here, so you can create these policies very similar to how you create a Dapr component. You can say AZ container app resiliency create, and then pass it a file, a YAML file that looks something like what I have below with all your policy definitions. But if you just want you wanted to opt into some resiliency without having to really get into the weeds and understand how your policies are going to work together. You just want recommended conservative policies. You just want your app to be some sort of resilient, have some sort of resiliency added to it. You can pass this -- recommended, and you can rely on container apps to provide some best practice resiliency policies. So this is really an easy opt-in to resiliency. If you just want some conservative resiliency and maybe you want to fine-tune the specifics later. And then lastly, we have the Azure portal. There's 2 screenshots. The bottom one here is quite small, but the idea is in your container apps now, there's a blade resiliency here that says preview. And we'll take a look at this in just a second, where you can define your resiliency policies, and then as well as your Dapr components. So those sit at the environment level, and you can add resiliency to each component that's being used as well. Cool. Do you want to see this in action? Should I show a demo?
Yeah, let's do demo.
All right. Let me switch over to my browser. Hopefully you can still see everything. We still good?
Yes, we can see your screen.
Great. Okay, so this demo is, everyone's probably seen this many times. If you haven't, this is one of the, I'd say, hero scenarios, hero demos of container apps, the Azure Container Apps greatest hits. And the idea is, or the scenario here, it's 2 container apps. There's a front end, which is what we're looking at now, which making
Actually, before you go too far, we see the
Yeah.
PowerPoint window right now.
Oh.
You're basically showing a demo slide. And I was like, is he really going to, that's how he gets away? That's not what Anthony lets me get away with. Just showing a demo slide.
Share screen. It says I can share the entire window.
Or you can share the entire screen if you.
Screen. That's what I did wrong.
Yeah.
We good now?
Not yet.
Hopefully it's not my other monitor.
It was your other monitor, but like, let's see. Let's put this thing up there. There we go.
We're good? Whoa.
Like, yeah, not that one.
Okay. I'm glad it didn't show me other screen, which is just chaos of screenshots and docs and stuff. So anyways, we can see my browser now. We can see the sample app, right? This is, as mentioning, this is the hero kind of scenario sample. There's tutorials out there in our GitHub where you can set up this application if you just want a quick way to test out ACA. But we've extended this to bring in resiliency. And so as I was saying, there's 2 container apps. There's a front-end container app that's making a call to a back-end API. And the front end is actually just asking for a list of albums. And so the back-end container app is just returning this list of this JSON of albums. And what we've done is we've actually introduced or simulated a fault, right? So every time I think 2 out of 3 requests is actually going to return 500. So here's one refresh, return to 500. I refresh again, another 500, and then it succeeds, right? And just to show that it's actually the back end that's actually has this error introduced to it. 2 refreshes, and then it works. So if I just want to add some resiliency to this application to see, how easy it is for it to be resilient, I go into the Azure portal. I'm in that backend API because remember I said these resiliency policies are applied to the app being called. So here's the callee, the API. I go to the resiliency section and my app's communicating over HTTP, and all I want to do is add some retries. So I'm going to throw in 5 here, and some of these settings really around like the policy. So here it's, I want this to be an exponential retry. So it can get up to 10,000 milliseconds. It's going to retry on any 500 error. I can also say, if I don't want to be a 500, I can say only retry in a specific status code, or additionally these other status codes. Or if my response contains a certain header, and I can customize whether that's an exact match of a header, regex, things like that. So there's a lot of customization that you can do, really fine tune your resiliency policies here. But
you might command plus a little bit so that we can see the policies that are on the screen.
Cool, better?
Yeah.
Thanks. All right. So for the sake of this demo, 5 retries, exponential, we'll hit save. And hopefully, if I start refreshing, so I just hit refresh, worked, hit refresh again, worked, hit refresh again, worked, right? Just like that, those policies were introduced. I'm not seeing any errors, but just to prove, that I am still getting those errors and we're actually retrying, is if I go to my log stream, it's like so big on my screen, but yeah. So if I refresh, I'm still seeing those 500s coming in, but we have those retries until I eventually get that 200 success. So the failures are still there. Now, and what I love about this is just how fast those policies, I didn't have to restart my app. I didn't have to, it just took effect immediately. And the last thing that I will point out before I give up the stage is you might be wondering, well, how do I've configured these policies, but how do I know that they're taking effect as I expect, right? Well, there's the observability for resiliency is really great as well. So we have logs for every time a policy has been, these are system logs. So anytime a policy has been applied, there's an output here, and we actually will dump out the entire policy rule in these logs. So you can see, all right, well, I know that my container app successfully loaded these policies, but again, like, how do I know that they're being triggered and applied? And for that, we have metrics. So you can actually go in, oh, my session expired, but hopefully you all saw that for a split second, but you can actually go in to your metrics, and you'll notice that there are some new metrics that you can sort by. For now, I have resiliency requests, retries. There's a little bit of a delay with these, but you can see they start to kick in, right? So there you can actually make sure that you're starting to see ejected hosts, which is their circuit breakers, timeouts, connection timeouts, things like that. So you can really dial in and make sure you're seeing that behavior and things are being triggered as you'd expect. Cool. That is resiliency. So yeah, I'd love for folks to give it a try. I probably should have put links in. I know Anthony, you probably will follow up with these, but put links to the documentation. You can find it in the Azure Container Apps, pretty much at the very top of the table of contents. There's a resiliency section for both service discovery and component resiliency.
Yeah, it's a really cool feature. Yeah, Thomas here actually has a question.
Sure.
And Thomas uses Poly in his .NET app, and he's kind of wondering, what should he use now? Now that there's resiliency in container apps as well.
It's a good question. I think Thomas, it really depends on your use case. The biggest difference that I understand. Again, I'm also not a .NET developer. My understanding is Poly is very much instrumented in your code, whereas this is provided by the platform, right? So if you want to just rely on resiliency, more of a declarative model where I can just opt in via the platform and I don't have to wrap up my operations in certain policies, that's something that you could do with ACA. But if Poly's working well for you and what you're using now, then I would say continue using that.
Yeah, and I would say the main difference is where you apply the policy. So in .NET, using Poly, you would basically install Poly onto your client app.
Yeah.
And you define your policies there. And obviously, since you're doing it in code, you have a lot more control over what you can do. If I could actually see a world where people are mixing and matching ACA resiliency with Poly. So having maybe some common resiliency policies enabled at a platform level,
yeah,
but then have more fine-grained control from your client app where needed.
I think Richard points out a good detail here too, right? In some cases, I remember working in the past, and there's different teams and they have different preferences for language choices. And so, is the opposite of polyglot app? Is that a monoglot? Is that right? So if you're in a monoglot environment where everyone uses .NET and you have, you can easily tell everyone, hey, we're upgrading to this version, and everyone is happily upgrading. I think that's my personal preference would probably be to stick with app side resiliency, right? But oftentimes that's not the case, right? And you have .NET mixed with Java or Node on the front end. And so resiliency is really much more difficult to achieve. And so leaning on the platform maybe is the right answer in that case.
Yeah, and Richard here has a question about, can you set up resiliency on calls that are outside of container apps, I think?
Yeah, so not yet. Something that we are discussing. And this is a public preview, so it's very much just the beginning of resiliency in ACA. But those are the types of things that we love to hear, right? That influences what we do with resiliency next. And so if there is the scenario such as this, I'd recommend opening up an issue in the Container Apps repository. And one of us will see it. And for now, it's pretty much just calls being made to a container app within the container app environment.
Cool. Yeah, but like Nick said, if you have a need for these having resiliency policies on external calls, we'd love to hear it.
And that is something we are actively discussing.
Nice. All right. Let's just quickly throw up the slide again with the announcements. So the next two are vector database add-ons and cloud build. And I think, Simon, you got a demo for us.
I do have a demo, yes. Let's see how that goes. It used to, I did this demo at Ignite, and it took 5 minutes at the time. So let's see if there's a few things that were cut off that I probably would go into detail on.
This is the director's cut, I guess.
This is the director's cut for sure. Did you already cut over? Yes.
Yeah, we see your browser with the PowerPoint slide.
Awesome. Okay, so I wanted to set this stage first. So this is a demo that, to some degree, also showed off the GPU workload profiles. We're going to spend less time on that today, but mostly the vector database add-ons, right? Add-ons was something that we introduced to build, and this time around, we added some vector databases, and I'll show that in more detail. And then the idea being that on the right-hand side, Jupyter and Quadrant are more the domain of a data scientist, maybe someone that is familiar with ML and AI. I found vector databases personally really interesting because they allow to build some really cool things. In this case, we're going to be building a music recommendation service, so kind of like a Pandora, essentially. So we'll ingest this data, in this case, the songs. We'll crank them through the Jupyter notebook. I'll walk us through that really quickly. And then we'll store them in the vector database. And then I'll show how to use the vector database really briefly. But then we'll have an API or a Python app that provides an API on top of that, and then a Java front end to actually see what happens here. And so we'll be looking at the vector databases as well as our new functionality around deploying uncontainerized or non-containerized source. So not images and not source that has a Docker file, but actually source that is just of a particular makeup, and using the build packs to actually bring that online in this case. So, all right. So with that said, let's go and get started. So I wanted to show off really briefly, and this is what I did here as well. Oftentimes, data scientists are not very infrastructure focused, and so ACA actually provides a great place to kind of work together with them, right? And I'm going to show off the new functionality around add-ons here. Most of you are familiar with how to create a container app. We've refined some of these choices here, but essentially you could very easily go and essentially say, hey, I want to go and deploy a Jupyter notebook. And I think one of them, right? I'm not going to do this now, but basically deploy the Jupyter notebook, and then there's now a new tab here called bindings. And in here, it's actually very easy to then actually spin up your add-ons. In this case, we're going to be picking either a new one, right? So in this case, we can just say Quadrant 2 and choose Quadrant. And so when I bring up this app, actually, I have both my front end, in the case is Jupyter, and then as well as my back end already connected, and I can start using them. And that's what we're going to do next. So here I have my Jupyter notebook. You guys can actually follow along. There's a tutorial for the Quadrant vector database that actually will get you to exactly this point as well. Kind of, for someone that hasn't used Jupyter before, it's essentially a live, interactive way of interacting or executing code. We can essentially do some basics here. In this case, I'm going to just run the imports. Let's see where we are. Okay, this is also downloading some. There we go. Perfect. Okay, so just some basics, establishing the connection here. That you can see that I'm using that Quadrant host, that variable that basically gets automatically injected when I use my add-on. And then I just do some basics around like, hey, is my database actually already there or is it not? And so we can move on from here. The container comes with a set of data already injected inside of it. This is basically, we can read that and this is, let's see, yeah, some forward warnings. We can inject that data, and then, in this case, we deal with songs, so I can actually go and just, load one of those songs. And I've loaded the songs from the data that I've ingested. And this is kind of to simulate some of the data science work that might be ongoing by someone, right? So we can actually listen to this. There's the song. And then we get to this point of creating embeddings. And here I'll want to spend a little bit more time. So you've heard this before. If you haven't heard, you will likely hear this over the next year or so, depending on where you are with your journey. But embeddings are basically, the way I kind of thought about them is essentially they're like fingerprints. Anything can have an embedding. It's essentially takes some piece of data, in this case music, but it also happens with text, right? So like if you've heard of this RAG model that is very popular with LLMs and kind of sideloading your own in-house data, that also utilizes embeddings. And essentially what happens is an embedding takes a piece of data and breaks it down into something that then can be compared. And in this case, we're breaking down this music data and essentially generating embeddings for that. And we're going to download this model. Unfortunately, I haven't downloaded this in this instance yet, so this is going to take just a split second while this loads. And so when you then generate an embedding, i.e. fingerprint, for one song, you can essentially then compare that embedding with another song in the process. And so you can very easily build a recommendation service. And since we actually technically don't have to do this because I'm doing TV Kitchen here, we can actually go and dive right into using some of these. And so, let's skip this because this is actually loading, but we can just, for example, use this here. If it doesn't crash on me, if it does crash, then I'll have to do some quick fixing, but let's see what happens when I just execute this cell. And is my timeout? Maybe it doesn't. I'm not entirely sure. Let's see. But this is super. So I think the most important part about this is this piece, and we can try to execute this here and see if it runs. But the vector database actually makes this super, super, super easy. And it essentially says, hey, for, let's see, for this particular song, and I'm pointing out the embedding, give me the recommendations back, right? So here, for example, I can actually specify a positive as well as then negatives, and it provides a complete recommendation service. So I used to be a listener of Pandora. That similar experience you can basically then build from scratch very easily here. And so let's take a brief look at this right there. So this is the recommendations service that sits on top of this that we briefly looked at, or that we're building. Let's load this real quick. Hopefully this comes up. See what still running over here. Come on. Let's see what this is doing really quickly. Well, we'll wait for this to load. Anyway, so the data scientist is done. I've computed my embeddings. In this case, I think is another interesting use case for GPUs here. I actually ran this, generating these embeddings across 11,000 songs on my regular workstation at first, and it took me 6 hours for roughly 2,000 songs. And then I cut over and used the GPU load the profiles in this same amount of embeddings, same amount of calculations or embedding generation. Basically only took about 45 minutes. So here again, we have a pretty good speed up of like how quickly this happens. The whole set eventually, takes on a GPU, takes between 1.5 to 3 hours, so 11,000 songs. And then the similar set would take between 15 and 30 hours on just a standard CPU. Anyway, the data scientist then generates these embeddings, they check out, and they hand this over, and now a traditional developer could come in and essentially connect to this this system. So in this case, you can see this is my add-on right here. I can now go and say edit and basically say, okay, as a data scientist, I am done with this portion and I want to go and disconnect from this. And then I could just disconnect and boom, a new revision gets deployed and the new revision will no longer be connected. And now I can use my Python API or Python frontend for the API to then actually go and connect to the Quadrant database. And this is still timing out, loading, I guess, in this case. I don't know why this is not loading. I can try to show, let's see if I can pull up the backup system. Any demo has a backup system somewhere. So,
this is how we know it's a real demo.
I know. Let's see if this comes up. Yeah, the only problem is the demo doesn't really, let's see, come on. Nope, they're both gonna get stuck here. That's very upsetting. Okay, anyway, there is a video online of this working. I'm really bummed out that it won't work here. Let's try to see. Maybe the backend is timing out. Yeah, this isn't going to load. Anyway, the outcome would be we get a list of songs. You can click on one of those songs. Actually, let me see if I can pull up the Ignite demo just to show it to everyone. Hold on a second. Yep. And let's see. This is the backup. Show you guys what that looks like when we're done. And unfortunately, I gotta go and dig through the video. It's right there somewhere. Perfect, actually, yeah. So let's we can watch this one too. So the front end, this all worked a lot better. So in this case, the front end actually is a jar. So this is interesting probably for developers that are less familiar with, bringing or building containers. So in this case, I'm bringing online a jar. I'm going to mute this real quick. Full screen this maybe too. So this jar actually then gets packaged using build packs, which is also something that we've kind of expanded on. We first launched this at build, but now actually we have build pack support for a whole bunch of additional languages: Java, Node, Python, .NET. They're all now supported. So in this case, the customer does not, or the user doesn't have to build a Docker file, make a Docker file, anything like that. And then we have the recommendation service here, which then basically allows us to, pick any school, and then get a recommendation with the score added. And then the scores are actually quite amazing. So yeah, it's super easy to build all of this. So that's all I had. Sorry, it didn't work all the way. I'm still working on actually getting this fully online so you guys can use all of it and recreate it as well if you want to.
Yeah, it's all good, but you showed everyone how to get to the video for your Ignite demo.
Yeah, exactly. That was the important part.
Yeah. We have a question here for you, actually, from YS. Great presentation. I guess they really like your blinking blue bar of disappointment.
Oh, yeah.
But yeah, I guess are there ways to configure a like a vector database, or do you just have to use the default settings?
So at the moment, all the add-ons are basically configured by us. They're in the case of Quadrant, the configuration is actually like the piece that actually kind of is the thing that matters, which is essentially like what kind of embeddings are you going to be loading, that kind of stuff, is all done on the client side. It's part of the notebook that I shared as well. So you create it's called a collection. You create the collection, and then you kind of specify, hey, how many bits or bytes do I want to use for my actual vector? I think for these I used a 2048, and that has to match what kind of model you use to generate the embeddings. And so most of the configuration happens on the client side. There's really very little like backend configuration. There are ways to change the CPU and the memory, but they are quite hacky at the moment. We're going to be working on this over the next couple of months to actually make that easier for people to use as well. So
nice, awesome. That was a pretty cool demo, and thanks for not playing the music. We didn't want any copyright strikes here. Okay, cool. Yeah, I think we can pretty much wrap it up here. Anything else y'all want to share, talk about? No, just silence.
Thanks for having us online.
Yeah, thanks for joining. Otherwise, it'd just be myself. It'd be pretty boring.
I guess next one, right? You're gonna have a different crew.
So next one, we're gonna try to have one in the beginning of January. So we try to do this on the first Tuesday of every month. So yeah, please join us then. Until next time, thanks everybody.
See y'all.
Yeah, thanks.
Bye.